The first person to theorize about atoms was the Greek philosopher Democritus. He thought that they were solid, hard spheres, and he called them atomos, which is where we get the word atom from. Atomos in Greek means indivisible or indestructible, so it's something that cannot be split. The next model was provided by Thomson. He had discovered the electron by using cathode ray tubes, and his model was called the Plum pudding model. Probably the best way I can describe this, think of it as being almost like a blueberry muffin. And so he thought that the muffin portion itself was positively charged, and then the electrons were like the blueberries, where they are interspersed throughout the positive things. So that's the Plum pudding model. Rutherford concluded from his gold foil experiment a number of things. First off, he knew that there was a tiny dense center where almost all the mass was located, and he called that the nucleus. The other thing he knew is that the nucleus had a positive charge, because as he fired positive alpha particles toward it, when they got close, they deflected away, either to the left or to the right, meaning they had the same charge. But usually those alpha particles pass straight through, and so he theorized that atoms are mostly empty space. And so for the Rutherford model, you have that tiny dense positive center, the nucleus, and then the electrons are somewhere outside, but mostly nothing there. Niels Bohr proposed this planetary model. This is probably a model you learned in middle school, where you have the electrons orbiting around the nucleus, kind of like planets orbiting a star. One thing Bohr said was that electrons were able to move from energy level to energy level, either as they absorbed or released energy. Schrodinger proposed this electron cloud model. Largely, he is known for his uncertainty principle, which basically explains that electrons, you can never tell exactly where they are at any given point in time, but you have an idea of where they're likely to be. Probably the easiest way for me to explain this, think of the propellers on an airplane. All right, if the propeller's sitting there buzzing around, zipping around, you can't tell at any given point in time where those propellers are. They're moving way too fast. But at the same time, you have some idea where they're likely to be, because you can see where they distort the light, and you can see the path in which they travel. So even though you can't see the individual blades, you can kind of tell where they're at. And that's kind of the same thing with Schrodinger's model of the electron. Of the atom. He called that the electron cloud. So you can't really see where the electrons are. They're buzzing around too quick, but they're somewhere in that area. And our last contributor was Chadwick. Chadwick was the one who discovered the neutron. Basically, he realized that the mass of the atom was not totally dependent solely on the protons. He thought they were way too massive for just the protons to provide all the mass, and so he theorized that there was some other subatomic particle he called the neutron. But basically, it's very similar to the previous models, the protons in the center, the electrons in clouds surrounding it. The only difference, you have the neutrons there, and they are exerting the strong nuclear force, holding those protons in there, preventing them from flying apart.